Okay, our next area of measurement is to have a look at the surface area of some three-dimensional shapes. And firstly, we're going to look at prisms and cylinders. Now, prisms are defined as three-dimensional shapes that have two congruent ends. The ends of the three-dimensional shape have the same shape on them. So think Toblerone, think can of baked beans, think box. These are all prisms. They have the same shape on each end. So I'm an absolutely woeful drawer, but I'm going to have a go at drawing a couple of these things. So a rectangular prism, sometimes called a cuboid, has all rectangular faces. So if we have a look at having a look at some sort of rectangular prism, this would be roughly our layout for it. Some invisible sort of sides there. That would be a rectangular prism, and have a please note the sides, the opposite, the two congruent ends. So in this case, our end could be this side here, and then one over the back. Or it could be this side and this side. There's lots of ways you can configure a rectangular prism because they're all rectangles. If we have a look at, perhaps I'm going to try and draw a triangular prism, which is the Toblerone, and I'm just going to have a little dig at that. So we have, if I try and draw this thing like so, you might get an idea here that that is my attempt at a Toblerone. So here's our, if you have a look at our congruent ends, in this case, triangle here and triangle here would be our congruent ends, making this a triangular prism, because the prism is defined by those ends, by those congruent ends. A triangular prism. The other way to think about it is if you slice a prism parallel to your congruent ends, then you will end up with two shapes that are exactly the same. You'll end up with two triangular prisms. In this case, if you sliced here, you'd end up with two rectangular prisms. And in the case of the cylinder, which is also a prism, its congruent ends are circles. So it is a circular prism, but it is known as a cylinder. That's our cylinder. So if we sliced it parallel to its circular ends, we'd end up with two stumpier little cylinders. Right in here, circular prism. Okay, so there's my attempt at a few three-dimensional shapes. Now we're looking at finding the surface area of these shapes. Well, in the case of the rectangular prism, you've got 6 rectangular faces. And if you have the dimensions of those faces, you treat it like 6 area problems that you need to add together. So if this was 7 by 2, this would be 14. So the back would be 14. If this were 8 along here, then this would be 8 by 2. That would be 16. There'd be 16 over there. And so you'd add all those faces up, and you'd have the total surface area. In the triangular prism, you'd do the same, except you've got a triangular face here. So you need the height, obviously, to take half height times base. Do the same with the triangle over the back there. But your other sides, your two sloping sides there, they are rectangles. So you'd have 2 rectangles here and 2 triangles to add up. But they're all essentially extensions on what we were doing in the last section on area, just 2-dimensional area, but just a collection and a sum of faces. The cylinder, however, cylinder can be broken down. We just need to look at the cylinder a little more closely, because if you break this up, we've got a circle on top and a circle underneath. Now you know how to find the area of a circle. Well, that's pi r squared there, and there's another one there, pi r squared. So they're two faces. The third face, if you roll this out here, and you imagine if you sliced this, can or whatever this thing is here, and rolled this thing back, what you'd end up with is a rectangle. So this is the net of the cylinder. You've got a circle on top. You've got a circle underneath. Both of those amount to areas of pi r squared. Pi r squared there and there. Now your rectangular rollout here, it's got, well, let's think about that. What does that there, that is the height of the cylinder. So we need to be given the height of the cylinder. But now what's this length here? This is interesting. If we roll that out, actually it turns out to be the circumference of that circle. If you think about rolling this, slicing this curved surface here on the cylinder and flattening it out, then what you've got here, this dimension is actually the circumference of that circle. The circumference of the circle is 2 pi r. So the area here of this rectangle is 2 pi r times h, 2 pi r h. And if you add in the two circles, then the surface area of our cylinder is equal to 2 pi r h, which is the rectangular bit, plus two circles, 2 pi r squared. So there, you'll need to apply that formula to find the surface area of cylinders. And for other types of prisms, you just need to add the faces up to get your total surface area. Your exercise now on this is exercise 6D on page 388. Please refer to the work requirements on that. I am not going to be in class on Friday, or in fact next Tuesday, as I'm away at an IB conference over those days and over the exit. So please come to class prepared to work. I will not be there, a cover teacher will be there, but you've got the work requirements, and now hopefully you've got the material you need to be able to complete those. Have a great exit. See you later.